link aggregation principle. Because we talk about the STP, right? And we also know the function of the STP. But we also found some disadvantage of the STP. Because if you enable the STP, at least one link. Okay. The presentation at the last day of the training, I will make it and send to your email. Okay. And about the STP, we say if we enable this one, at least one link is broken. And because we hope we can avoid the loop, so one link bandwidth will be wasted. But if we use a link aggregation, we can make multiple physical ports together like a logical ports. And every traffic can use the logical ports automatically. And we also can provide a load balance here. So all the bandwidth can be used. This is the advantage of the link aggregation. After taking this course, I hope you can understand what is link aggregation and what's the advantage of here. And we have two types of link aggregation. One is static and another one is dynamic. If we use the dynamic link aggregation, we will use a protocol. This protocol we call is LACP. And later we will talk detail what is LACP. And the third one, we have to master the principles, the configuration, and also some basic maintenance of link aggregation. And the link aggregation also is very easy to understand and to do the configuration. So in lots of scenario, many engineers hope to use link aggregation rather than the STP. Okay. Let's see why we will use the link aggregation. Like this scenario, if we only have the topology like this one, there is a single failure problem, right? If one link or one device is broken, the network cannot work with each other. So if we want to the core switch have the higher bandwidth and also have the redundant backup, we can add a new link. For example, we have two links. And about this link, if we don't use any protocols, there is a loop, right? The left one sends the message to right, and the right will send to left again. So some scenario, someone maybe say, we can use the STP. If we deploy the STP in these two devices, at least one interface will be broken. If one link, the bandwidth is 10 gigabit, two link, usually we have 20 gigabit, but finally, if we use STP, the most time bandwidth can be used is 10 gigabit. So if we use the STP, we can get the redundant backup of the link, but we cannot improve the bandwidth, right? So this is the problem of the STP, especially in your data center. In your data center, maybe the bandwidth is higher like the campus, maybe 10 gigabit, 100 gigabit, even though 400 gigabit bandwidth. You say I have three links, but only one link can work. The other two links maybe only wait. This is a big waste. So if you want to use a lot, if you want to use all links, we have to another technology like link aggregation. And about the link aggregation, pay attention about this part. Link aggregation in radio devices. We also use the aggregate port to indicate the link aggregation. This is a logical interface. If we use the technology, we can combine multiple physical interfaces together to become a logical interface. So sometime maybe you will see the name like AP. This is aggregate port. This not is a WLAN AP access point. It's different. Pay attention, please. And about the aggregation standards, we use IEEE is 802.3AD. And about the advantage of the link aggregation, we can extend the link bandwidth, right? Because we have two links and after we do the combine together, we can have double bandwidth. If you have three, we have three times of the bandwidth. And also this one can provide the auto-link redundancy backup. Because if now we combine two link together as a logical interface, and all the traffic can be forwarded load balance. If one link is broken, this traffic also can be forwarded to the other link automatically and immediately without waiting. So this is a second advantage. And the third one, we can provide multiple traffic balancing on the aggregation link. We have lots of choice. If in your network you have different type of traffic, you can provide the load balance like based on the MAC address or maybe based on the IP address, something like this. Okay, so this is the advantage of link aggregation. And about the link aggregation mode, we have two types. One for static. And about the static means we don't use any protocol negotiation between two devices. And the port state of drawing the link aggregation or leave the aggregation, we have to do the manually assignment. Add one, add two, or maybe delete one, delete two. And we have to use a command to create and delete the static link aggregation group. So this is the static aggregation. And another one for the dynamic aggregation, we have to use the protocol of LACP, Link Aggregation Control Protocol. And this one is used in the devices to do the negotiation. For example, which interface can be the member in the group? Because maybe in your network you have different bandwidth, different speed of the interface. But finally, we will select someone who has the same speed and who has the same, for example, duplex mode, something like this. So we have to do the negotiation. If we use a dynamic aggregation, every parameters will be added into the LACP package, and I will send it to the other side, and we can do the negotiation. But if you use a static one, we cannot. I don't know what's the parameters of the other side. So finally, maybe at last, there's a mistake when we transfer the message. But about the dynamic, you have to know with suggestion, the same vendor devices, you can use the LACP, but different vendors, maybe there's some parameters a little different in the LACP. So the negotiation maybe have some problems. So in different vendor, we suggest to use a static aggregation. But you have to keep the parameter like the speed, like the VLAN configuration, like the other parameters must be same in two devices. Okay, so this is the dynamic. And the port status drawing the group successfully or not, you have to leave. This one will be automatically maintained through the protocol. And the group, you also have to use a command to create or delete. So these are two different places. And about the dynamic aggregation, we also have two types. One is active and another one for passive. Active means the port will initiate LACP message negotiation, but the passive, I only respond to incoming LACP packets. That means if you are in passive status, when I send the message, I will not directly send the message to you until receive the message from your side, and then I will give you the reply. So if two sides in rigid devices, you configure all of them to become passive, they cannot do the negotiation. At least one side to become active. Pay attention about this part. And both the interface of layer 2 and layer 3, all of them can be configured on the static or dynamic link aggregation. We can support. And after we do the link aggregation, One advantage of this technology is we can provide the traffic balance. This means if we have four links here, like this topology, we hope at least 25% on one link and not the result everything on one link and the other three link is empty. So how to provide the traffic balance? We have lots of methods. For example, to configure the balance based on the source MAC address. If the traffic have different source MAC address, we can choose different link. But if you send a big traffic and they have the same parameter of the source MAC address, source IP address, and the destination MAC address and destination MAC IP address, you cannot provide the load balance. At least for different parameters, then you can use this function. Okay, and the flow balance mode can be different for different type devices. That means like this topology. On this switch, we will force the traffic for load balance if they have different source MAC address. But for the upper devices, if they go to different destination MAC address, we will provide the load balance. Okay, because when we do the negotiation of dynamic in the LACP, we will not add these parameters. So different type, different tools we can use for different devices. And after we finish the configuration of load balance, we can use the command show aggregate port load balance. And this is a command. And it will show you what the link load balance type based on the source IP address and the destination IP address. If one parameter is different, maybe we will transfer the traffic in different link. So this is a traffic balancing. And the second one is for the link aggregation configuration. The static configuration is here. First, we have to create the Ethernet AP port. So pay attention about this one. This AP is aggregate port, not about the AP for WLAN. Okay. And the aggregation group works in static aggregation by default. Okay, so if you don't add the special for dynamic, the default type is the static way, and the command is interface aggregate port and give the port number. But pay attention, you will find this is an optional command. That means if you don't create the AP port, you also can create automatically when you add one interface into the AP port. So this is why here we will use the optional. And then we have to add the interface into the AP group and to become the member ports. We have to enter the interface in the interface type and the port group and give the AP number. If you create the first step, you create the AP port, you can directly use the port number. If you don't use this command, and here you directly to use the port number 1, that means the AP port 1 will be created automatically. And if you want to make this AP to become layer 3 interface, you have to add this command, no switch port, right? No switch port. If you configure the physical interface as a layer 3 interface, you also have to add this command too. So by default, your aggregation port is a layer 2 interface. And if you want to use layer 3, you have to add the no switch. And you also can choose the traffic balance mode to become destination MAC, source MAC, or something else. So this is a static way. And here is an example. For example, now switch 1 and 2. Interface 1 and 2 and directly to add into the port group 1, right? We don't create the AP at first. Because if we directly add the interface into the AP, this will be configured the AP port 1 automatically. And then we enter the aggregation port 1 to give the configuration of layer 2, like switch the mode to become trunk. And then all the physical interface will get the configuration of trunk. So pay attention, you have to add the physical interface into the link aggregation at first, and then do the configuration of layer 2 in the interface, in the aggregation interface. Pay attention about this one. And then to aggregate the load balance to become source and destination IP address. Please wait, I have to mute. Okay. So this is a configuration of static link. If switch 2, we have the same interface connection like switch 1. We only to use the same configuration on switch 2, it's enough. Okay. And about the dynamic aggregation is a little different. First step, you also can create the AP port at first. Then you have to add the interface into the port number. Of course, when you add the interface into the group number, you have to choose the mode to become active or passive, at least one. And you also can change the priority of the LACP of system operation and port operation. Why we have to change the priority? Because when we use the dynamic link aggregation, we have to decide all the interface added into the AP port, who can be finally the member, who cannot. So we have to select one rule like the root and compare the rest interface, compare with the root port with a special port. If the parameter like the speed, like the configuration of VLAN, something like this is same, they will be the member. Otherwise, they cannot be the member. So how to select this special port? We can change the priority, and the lower value priority will be the better switch at first. And within the switch member port, we will choose the lower priority of the port interface to become the special interface. That's why we sometimes need the command to change the priority. Okay. And finally, also, if you want to create the aggregation ports to become layer 3, you have to add the command no switching port and to select the traffic load balancing. This is a dynamic way. And the different command from the static is port group and choose a mode to become active or maybe to become the passive. If we use this command, and then the LACP will be enabled automatically. If you don't change the priority of the LACP, we will use the default way. So this is the dynamic link aggregation. Okay. And after we finish the configuration, we can use some command to check, like show the aggregation port load balance to check the result for the traffic based on the source or destination. And also we can use show aggregate port summary to check the aggregation port information. For example, like this here, we create the aggregation port number is 3 and the maximum port is 8. Pay attention about this one. Someone say, if I use the link aggregation, I can increase the bandwidth. So I don't want to buy higher performance devices. I want to do link aggregation in all the devices. So this one will also have the limitation. The maximal port of the aggregation port is 8. If you add 10 interface into the aggregation group, the maximum number is 8. That means maybe you will have a loop in this link because at least the 2 interface cannot be the AP port, right? And the second one, the maximal bandwidth you use is 8 gigabit, will not be 10. Pay attention about this part. And the switch mode is enable, and the mode is access. The port will be 1, 1 and 1, 2. This is a configuration of the VLAN. And also you can see the LACP link status, show LACP summary. Okay, so this is a maintenance. And another one for the note on the configuration of link aggregation. First, all the AP member ports must have the same rate and must be in full duplex. This is the first one. And must belong to the same VLAN if you use the layer 2 aggregation. The stream media should be same. For example, same optical port or maybe same electrical port. You cannot add the optical and electrical port in the same group. So this is the first one. And the second one, by default, the aggregation port created is the layer 2 AP port. So if you want to use the layer 3, you have to add the command is no switch port. And another one, for port security, if you want to add some port security on the interface, the AP port cannot use. So this also is a limitation. And another one, if you adding a port to a non-existent AP port, this one will be created automatically. That's why when I explain first command for you, I say this command is optional command. Because if we don't have the AP port, when you add the interface into the AP group, this AP port will be created automatically. So here are some notes we have to know. And another one is when a port added into the AP port, the port attribute will be replaced. For example, you already created the VLAN configuration on the physical interface. After you add the interface into the AP, this configuration will be deleted, and then you will use the AP configuration. Okay. And if the port removed from the AP, the port attributes will be restored before it was added into the AP. If you leave the group, the configuration of the AP also will be deleted. So this is the noted we have to know about the link aggregation. So that's all about the principle of link aggregation. And then we will find about this one. First, if we use a link aggregation and not over the maximal port in the network, all the bandwidth can be used. So this is very good solution in the redundancy backup and the message and the maximal usage of the bandwidth, right? So why in some scenario we still have the STP? Someone can explain it. After we explain the link aggregation, we will find the link aggregation is better than STP, right? Because we don't need to wait 30 seconds or at least 15 seconds. We don't need to wait. After we become the link aggregation member, we can immediately to use to enter the forwarding state and to help devices to forward the traffic. So why we still have to use STP? Link aggregation only can be used in the same group, in the same devices. For example, if now you have two switches directly to use the cable to connect with each other. In this scenario, you can use a link aggregation. But if your topology is like this, if here two are core switch, and here is an access switch, right? Connect with them. Here, you cannot use the link aggregation because the other side belong to different devices. So in this scenario, at least you can use STP or maybe other solution we talk about tomorrow, like the VSU or maybe the other technology like a VIP in the RegJ solution. So link aggregation, we have some limitation that different sites or different physical interface have to be on the same devices. So this is a limitation. Other one, I think the advantage is very clear. Although maybe you don't need the port security, link aggregation also is very useful. So here is a practice questions for you. Please show me the correct answer. What's the answer? B, right? Yes. In the passive mode, right? Passive mode means I only will give you the LACP message until I receive the message from you. I will give you the reply. So if both ends is in the passive mode, two sides will waiting. No one will send out the LACP message at the beginning, so they cannot be successfully. Okay, the second one, which of the following conditions may cause the port aggregation to fail? So which one is correct? Have some answer? A and C. A should be wrong, right? Which is port type should be same, both optical or both electrical. So A is wrong. B is wrong or not. One is gigabit optical port and another one is 10 gigabit optical port. We say the note we need to have the same speed, right? So the second also is wrong. How about the third one? When during the layer 2 aggregation, two members belong to different VLANs also cannot, right? They should be in the same VLAN. D, both member ports are gigabit 4 duplex electrical ports. Yes. So the first one is B, the second one is A, B, and C. The interface speed also should be C, gigabit or 10 gigabit. It's correct for you? This is a limit here. You must have the same rate and in full duplex and the same VLAN configuration if you use a layer 2 aggregation. And the transmission media also be same optical ports or same electrical ports. That's why this answer should be A, B, and C. Okay, so this is a part introduction of the link aggregation. Between the core switch, the bandwidth, we hope we can be increased and fully used, right? In this scenario, we can use the link aggregation. And about the link aggregation, we have two types, one for static and one for dynamic. And about the static and the dynamic, also both of them should be configured manually. And all of them support layer 2 ports and also support layer 3 ports. And the configuration also not very complex. And the key point, you have to keep the parameters the same of the physical devices, like the speed, like the full duplex, like some configuration of VLAN, something like this. So these are key point of the link aggregation. That's all about today's topic. So maybe now is the discussion time. Do you have any questions of today's topic? Yes? Do you have any topic, any questions we discuss together or not? Tomorrow we will explain about the VSU and the VIP and also the DHCP. So also three topics. No more? No more, maybe today is finished here. And we also have the lacquer group. And if you have any question, you can directly feed me back or maybe contact with your region personal sale and to tell me the suggestions. Okay. And I hope tomorrow the same time I can see you again. Thank you guys. The presentation and the video we will send you to the email at the last day. Okay? Thank you guys. Bye.